Hello class, this is Ms. Chakoi. So right now it's just vectors. We'll get into how vectors connect to kinematics and actually a lot of different things in physics. But just in general, remember, vector is any quantity that has a magnitude and direction. So that would our velocity, acceleration, we get to force, momentum, all of these things are vectors because they have a direction. So you need to know how to draw them, how to find the resultant vector, how to find the components of a vector, and then how to find the direction with an angle. Alright, so we essentially have a list of directions: 2 meters north, 3 meters west, 1 meter south, 4 meters east, and 2 meters west. So a question that would often be associated with this would just be like, what is the displacement? So just from looking at this, you know they're probably not at the origin, but really you don't know. So you have to write out all of your components. So you just need to pick a starting point, and I'm just going to call each one of these is 1 meter. So if this is our origin, we go 2 meters north. Next is west. Go 3 meters west. Then we go 1 meter south. Then we go 4 meters east. Okay, well, we're actually looking like we're pretty close to the origin. 4 meters east. And then last is 2 meters west. So if you remember, so this is where we ended. This is where we started. So you can actually see our displacement is quite small. And so to find your resultant, what we do, we call this, we draw tip to tail. So here's the tip, there's the tail. That black is my resultant vector. So we can actually find the distance. If we know this is 1, this is 1, it just becomes a Pythagorean theorem problem. And so we know that our resultant vector is the length square root of 2, and we will need the direction. This would be in the northwest direction. From this, you can also figure out what your angle is here. So I'm going to just enlarge that. So we know this is square root of 2. A lot of times I want to know what your angle, or theta. We often use the Greek letter theta to mean our angle, if you have not noticed that already. So depending on how good you are with triangles, you might be able to just look at this and be like, wait, that's 45 degrees because these are equal on each side. If not, we'll go over how to find them in a second. Alright, so just pause the video and try this on your own. So this is find the resultant. Alright, now that you've had a chance to pause that, just pick somewhere as an origin, and we can say we have gone 2 meters west, 4 meters south, 3 meters east, 5 meters north, and then 8 meters south. So put your origin here, resultant here, tip to tail drawing, so we can tell this is 1, this is 7. So again, we can use Pythagorean theorem to find your resultant from that. square root of 50. You can also find your angle. On these, make sure you're very clear which angle you are doing. If it's the angle off of the south, that's fine, and that's actually the one I'm going to pick. So we don't necessarily know what that is, but we do know some trig. This would be your SOHCAHTOA. And let me just erase to make this a little cleaner and easier to see. If you're having troubles, I would expect you to redraw it. Alright, so this is most definitely not drawn to scale, but much easier to see. So you want to find this angle. It doesn't really matter. You can, since you know all the sides, you can use any one of these to find it. I tend to go with tangent, but that's just because I like that I already knew these in the beginning. So you know that tan of theta is equal to the opposite over the adjacent, so that'd be 1/7. And then you should have this button on your calculator where it says inverse. So what this does is if you hit this button and then do 1/7, that'll give you your theta. If you plug it in, you would get 8.1 degrees. Make sure you're in degree mode, not radians, or you would have gotten a different answer. Also, always think, does it make sense? And yes, our angle should be really, really tiny because the one on the far side is very small and this is very long, making our angle very small. Always check back and be like, did my answer make sense? Alright, while we often have to find the resultant, more commonly, we have to find the components. So what that means is if we have some vector, and let's call this 40 degrees. If we have some vector, it doesn't matter what it is, let's say this is going at 30 meters per second, there is both an x, I'm going to change, that's not a very good color to use, and a y component to it, where y is our up and down and x is our horizontal. We're going to use that color. So you need to be able to find them because we're going to have to break things up. Things can act in multiple directions, but those directions do not get to be combined, as we'll see when we do more problem solving. You need to be able to break them up reliably. And the best way to do this is SOHCAHTOA. Later, you're definitely going to be able to just take shortcuts, but make sure you practice now. So if we're finding y, you can think that this is the opposite and the hypotenuse. So if we're using the opposite and the hypotenuse, we would use sine. So we know that sine of 40 degrees is equal to our opposite, y, over our hypotenuse, 30 meters per second. You move your 30 meters per second over, multiply it by sine of 40, and you'll get y. It should be 19.3 meters per second. You are going to keep your units for these. And then if we do our x, we'll notice that it's the adjacent and the hypotenuse that we know. Although I suppose you could use tangent because now you know y. It depends what you know. Oops, I was going to skip a step. So cosine of 40 is equal to x over your hypotenuse times cosine of 40 equals x. And you'll notice there's starting to be a trend, and actually this was me going to skip that step. Eventually, I just want you to make sure you know why it's that way. Eventually, you will get so used to it that you can just skip that step. And you would get x is equal to 23.0 meters per second. This is if you rounded, which you should. And again, always ask yourself, does this make sense? Yes, this makes sense because this is 40 is relatively close to 45, so these should be really similar. because in a 45-degree triangle, these are the same distance. Alright, while these are not exactly drawn to scale, find the x and y components for each one, and then come back for the answer. Now that you've tried them on your own, let's just find the y first. So if you remember, when you're finding y and your angle is in that direction, that's sine. So sine of 45 equals y over 10. So 10 sine 45 equals y. And y will equal essentially 7 meters. Another way that you could have done this, if you know your trig, you know that this side is x times the square root of 2, where each side of these is equal to x. And again, since you hopefully know your 45-degree triangles, we know that this is also equal to our x, which is also equal to 10 divided by the square root of 2, which is a radical, and we can simplify, but so if you simplify, you multiply your radical, because that's just 1, so we get 10 over times the square root of 2 over 2 times the square root of 2, which just gives you 2. You can simplify this, and that's 5. These are all equal. Just some thoughts. Okay, so 45 and 60-30 are like your two special. So this is a 30-degree angle, which also means we can do some special things. You can just solve it regular if you want. Remember, note, these are negative directions. So keep that in mind, that your answers would be negative in this case. But if you want to do y, we can do the sine of 30 equals y over 4. If you do this, you actually don't need to plug into your calculator. It's 2, because your hypotenuse is worth essentially 2y, and since this is y, if this is equal to 4, y must be equal to 2. This is essentially your whatever that y or x was times the square root of 3. So you could either do your cosine of 30 to find x, which would give you 3.46. This is in meters per second. Or you could just write it out as 2 times the square root of 3, because these are the same. Alright, now I'm going to clear some space because I kind of clogged up my area to do the other one. You can always go back and get whatever I wrote earlier. Alright, so this one, we have a y, we have an x. Hopefully you're starting to see some patterns, although remember that one of these is in the negative direction. Should have written that in blue. And the x is in the positive direction. Remember, these were both negative. So we're solving, hopefully you're starting to see patterns. Although, notice that this angle is in a slightly different direction. In fact, a lot of times the angle is done differently. So that's why you can't necessarily just assume which one is sine. It's not necessarily always y, it depends. So in this case, sine, the opposite, is your x. So sine of 20 is equal to x over 15. And I'm going to redo that in the color I was supposed to do that in. So sine of 20 is equal to x over 15, you move the 15 over. There's no special triangles here, so you just have to plug this into a calculator. If you do that, x is 5.1, and this is in newtons. We haven't gone over what newtons are, but it doesn't matter. It's just in the newtons anyway. And then we need to do the y, which would make y 15 cosine 20 is equal to y.
So this is 7, right?
It would be 14.1 newtons. And then remember, this one is negative because it is down. Alright, and then we are going to continue going over this in class. I want you guys to be very good at it, and then it's going to start showing up in problems.